of a gas, and we want it to be an ideal gas. The ideal gas is kind of like a model we use to describe the properties of this gas. And for an ideal gas, we know that we're going to say we have a large number of molecules. And all these molecules are identical, and they all move randomly. So they don't move together. They all just kind of fly around in different directions. And whenever they collide with each other or the walls, they collide with under the perfect elastic conditions. So there's no energy loss. So it's with this gas sample that this ideal gas, that we'll look at the idea of temperature and heat. And if we think of temperature now, and let's say we stick a thermometer into our gas sample, the idea of temperature can be thought of as being related to the motion of the gas. So if we added heat, let's say we put a flame underneath here, and as we added heat, what we would see is that the temperature of the gas would go up. But when we add this heat, when we put it under the flame, how is that energy going into the gas? Well, what it does is it raises the kinetic energy. So the temperature is related to the kinetic energy. And that's what we're going to say for our ideal gas, that the temperature can be defined as the average kinetic energy per particle of the gas. And so as your temperature of your gas goes up, so does the kinetic energy. And really what we're saying is, if the kinetic energy goes up, that means the velocities go up, because the mass of each molecule would be fixed. So really what we're saying is the average velocity goes up per particle because the kinetic energy goes up. Because we put in this energy and it has to go somewhere. So when we look at our ideal gas, the temperature is related to the average kinetic energy, which means it's related to the velocity. And so the total energy of the gas is just the total energy of all the gas molecules, their total kinetic energies. So this is our way to think about temperature. Our temperature can be thought of as being related to the kinetic energy per particle, which would be related to the velocity. So there's a temperature relationship between the motion of the molecules, their energy, which is related to their motion, and the temperature.